Given the following, and then they name two different things. Sorry, that's a bit blurry, isn't it? Can I make that?
Alright.
Is it alright? Can you guys read it?
Yeah.
That's better.
That's better.
Slightly. Okay. Given the following coordinates of points, that's what these guys are. Okay. And equations of lines, that's what these guys are. Plot and graph them neatly on the set of axes below, labeling each clearly. One grid, like one of these things, one grid square equals 1 unit. Okay, so we'll start with the easy bit, which most of you I saw did pretty well. We'll plot the points, right? The hardest thing to remember is you've got an X and a Y every single time, and it's alphabetical, right? X, Y, X, Y. So 2, 3. If I count one grid square, that's going to be 1, 2. That's where I'm going to be for an X, and 1, 2, 3. That's where I'm going to be for the Y, and they line up there. So that's where A is. So you can have a look at where yours is right now. That's A. B is 1, -1, so you're going to go to the right 1 and down 1. That's the -1 there. So that's where B is.
You got it wrong.
And our last point, -4, 4. Sorry, -4, I should say. So you go 4 to the left this way, and you go 4 down. So that's where C should be. Okay, so there you go. That's A, B, and C. Let's have a look at D. I'll do this. I'll do these a couple of different ways. So Y equals X plus 1. First, we'll do the triangle method. Do you remember this? What we need to do is look at this guy, right? Y equals X plus 1. And to do the triangle method, you need two things. You need the Y-intercept, and then you need to know the gradient, which is going to fit a triangle in there, okay? So what's the Y-intercept of this rule or this equation? So what's the Y-intercept? What's the Y-intercept? The Y-intercept's a particular number. It's this guy on the end. It's the +1, okay? So I know that this line passes through here. That's +1. Now, I need the gradient as well. Where do I read the gradient from here? It's hiding. It's a bit sneaky. It's the number in front of the X. You're like, there isn't a number in front of the X, which means it's 1. That's exactly right. So the gradient's 1. That means you go across 1 and up 1. That's the run, and that's the rise. Okay, so I'm going to go through here. So now, I get my ruler out. I'm going to go through these points. Let me try and do this as neatly as I can. Something like this. Okay, there you go. So they do say label each clearly. So I should say, well, this line I've just drawn is Y equals X plus 1. Okay? All right, let's do this one. Y equals -2x minus 1. The other way you can do this, the other easy way is using X and Y-intercept. X and Y-intercept. So there's a Y-intercept right there, -1. So that means I'm going to go through here. Now, how do I work out the X-intercept again? Do you remember how to do that? How do you work out the X-intercept?
It's the 2 in front of the X.
The 2, that -2, that'll give you the gradient. So I could use that to graph. That would be fine. But the other way to do it is to say, well, if I want the... What did I ask for? What if I wanted the X-intercept? The X-intercept. I'll say, let Y equal to 0. I wonder if that jogs your memory at all. Okay, so I put that into this equation. I get 0 equals -2x minus 1. Let's see, how can I rearrange this? I'll put the 2x over here, and then what do? I want to say x equals something, right? So I've got to divide by 2, yeah? So I get -1/2. Okay, so here's my Y-intercept. Here would be my X-intercept, -1/2, because there's 0 and there's -1, so it's halfway. So now I join them up. Okay, let me see if I can do this.
You can do it still.
I'll try.
If you don't do it, you know, you can always draw more lines. You know, you can get
yeah, just until it all looks good.
Don't have this.
Hold on, I'm just making sure this is. Oh yeah, okay, I see what's going on. It'll be something like this actually. There you go. Okay, so this is Y equals -2x minus 1. Now, by the way, before I think it was Jack said, you know, that -2 out the front. What's that going to be? That's the gradient, right? And you can see what that means is it's a steep. Excuse me. Excuse me. It's a steep line going down. Okay, so that's why you've got that -2 out the front. We didn't use it, but you can if you want. Last one. 1/2x minus 3. I'm going to do that the same way I did before. So you've got that -3 down there. That's my That's my y-intercept.
Here you go.
And I've got the gradient of a half. So that means every time I go across 2 units, I'll go up 1.
Horizontal. Rise.
Sorry, say it again.
We have to zoom in a little bit.
Is it too small? Let's try this.
No, it's massive.
How's that?
Ooh.
No, that's so big.
It's too big for
Okay,
my
alright.
Hey.
Wow, look at my enormous stubby fingers. Okay, there you
That's
go.
too big.
Doesn't
So-
that make you feel so self-conscious about your fingers?
I try not to
Looking
think
at
about
the
it.
nails?
Okay, here we go. There we go. That is y equals. Trust me, after you've looked at yourself on video for hundreds of hours, you stop thinking about it. Okay, there you go. There's your 3 points. 1, 2, 3, and then there's 3 lines. You got the picture. So yours should roughly look like that. Okay. I'll give you a warning. You'll get asked to draw graphs like this if they provide for you a set of axes, like I have, and a grid, like I have. They expect you to be super accurate, right? They expect the gradient of -2 to look like -2, and to be able to tell that different from. Can you see this one's got a gradient of 1, and this one's got a gradient of a half? They look different. They're not parallel, so you'll be expected to do that. Okay.